To take the derivative of b to the x, I must first show that this statement here is a true statement. Now, you can fast forward past this because this proof is actually something that you should have seen already, but as a good reminder, why is this true? Well, first of all, I'm going to need the definition of a logarithm. If a is raised to the b gives you c, then by definition, this is what a log is. Log base a of c must equal b, or this can be read, and when I say can be read, let me highlight it. The exponent that I place on a to get c is b. So that's how I read that statement in plain English. The exponent I place on a to get c equals b. So that's the definition of a logarithm. One other little definition we need is that the log base e of any number, I'll just call it a, can be written as the ln of a. These say the same. So ln just means log base e. So what I'm going to start with is this statement here, that the log of b to the x base e is equal to the ln of b to the x. And that's a fairly trivial statement because both of them just say the ln of b to the x. Okay, however, I'm now going to use my definition and I'm going to focus on this logarithm right here. And I'm going to take this logarithm out of logarithmic form using this property here. So let's talk about how we'll do that using this property. So first of all, I'm going to focus in on the components. I'm going to color code them. Where the e is here, it would be here, and that would be this number here. So I'm just matching everything, color coding things. And this number here is this number here, which is this number here on my two if-then statements. So I can go back and forth on my if-then. And last but not least, this whole side here can be rewritten up here using my definition. So using those color coding, I'm going to take it out. And again, my full emphasis is on this logarithm. So what I should have now is let's color code that. E2, let's see, this part here, ln of b to the x. And that's going to equal, keep that, the green component, which is b to the x. And again, all I did was focus on this logarithm and took it out of logarithmic form. One last little detail here. This property of exponents says I can rewrite this exponent as multiplication, giving me e to the x ln of b equals b to the x. This is very important because if I want to take the derivative with respect of x of b to the x, that's the same as taking the derivative with respect of x to e to the x times the ln of b. Now on this one, I can use my chain rule. So chain rule or U substitution, this is going to be e to that exponent times the derivative of this, and ln of b is just a number, might as well be a 2 or a 3. So if I had 3x on the top, then the derivative of 3x is 3, so the derivative of this is ln of b. Again, the derivative of my exponent is ln of b. So now I have this statement here. Derivative dx of b to the x equals e to the x ln of b times ln of b. Now, it's very important to realize something, that this is this. These are interchangeable here. Let me color code my connection there. E to the x ln of b is the same as b to the x, so with that little substitution, this equals b to the x times ln of b, and that is my derivative. Oops, I don't think I meant to do that. But don't know why that came in there. Okay, little arrows came in there. Sorry, don't know where that came from, but ln of b. So that is my final answer.